The standard that I chose to do this activity over says, compare two fractions with different numerators and different denominators, that is, by creating common denominators or numerators, or by comparing to a benchmark fraction such as 1/2. Recognize that comparisons are valid only when the two fractions refer to the same whole. Record the results of comparisons with symbols greater than, equal to, or less than, and justify the conclusions, such as by using a visual fraction model. So right here, we have the fraction 2/4, and then we see the sign equals, and then we have a blank numerator over 8. So my students would need to figure out what numerator can we pick, 1, 2, 4, or 6, to put over 8 and make it equal to 2/4. What I could have them do is use a highlighter or a pen and fill in 2/4, and then look at the one below that. How many do we have to fill in for it to be equal? Well, it goes from right here over to right here. So then they can look at these fraction bars, the comparisons, and they can easily see that 1, 2, 3, 4 eighths is equivalent to 2/4. And then they can use methods such as cross multiplication to check their work, although that's not completely necessary because we already have the diagram to check it. This next page is the same thing, except now we want 2/4 to be greater than this number. So same thing, we can fill in our 2/4 here. And if we want 2/4 to be bigger, then we know that we want the bottom fraction bar to show less than that. So let's just start with 1. Is that one of our choices? Yes, it is. So we can see with our fraction bar that 1/8 is less than 2/4, or 2/4 is greater than 1/8. Lastly, we can do this with a less than symbol. So now we have to figure out 2/4 is less than what over 8. This means that we want 2/4 to be the smaller number. So if we look at our choices, we know that 1/8 was smaller than 2/4. 2/8 is still smaller. 4/8 was our equal to. So our only remaining option is our 6/8. So my students could use that type of thinking process to figure out that the 6 would go over the 8 to make this true. Next we have where they can order the fractions to make the sentences true. So I have this set up so that we can easily convert to common denominators. So there's 2's, 4's, and 8's. So my students will be able to make them all into the same, or into fractions with a common denominator, whether that be on a whiteboard or in their heads or whatever, and they can see that we have almost all of the fractions for 8's. So they can start off with 1/8 and then think what is equivalent to 2/8, and by doing out their work they can see that 1/4 is equivalent to 2/8. Then we have our 3/8. Now we need to know what is 4/8. Well, that is also going to be 1/2. And then we have 5/8. How about 6/8? 6/8 would be equal to 3/4. Then we have 7/8 and 8/8. And once this lights up green, my students will know that they had the correct order. So I think that this lesson met 3 of the main standards, and that is empowered learner, where students use technology to achieve and demonstrate their competency. They use feedback to improve their performance. Obviously, they were using technology to show that they know how to compare fractions, and they can use the feedback, whether it be the sequence lighting up green to tell them that they're correct, or not lighting up green to tell them that they're wrong, or if it could be my feedback. And they would use that to figure out how to do it better next time. Knowledge constructor, students use a digital tool to construct knowledge, produce creative artifacts, and make meaningful learning experience for themselves and others. This is mainly demonstrated through the fraction bars, where they get to create their own artifact to visualize their math. And lastly, computational thinker, students employ problem-solving strategies that use technology to test solutions. Once again, the thought process of comparing the fraction bars would help them to compare and figure out the correct answers.